This is Into Math for 3rd grade, lesson 14.1, Relate Fractions and Area. I can use a fraction to show that equal parts of a whole shape have the same area. Please gather your workbook and a pencil and turn to page 386. If you need to pause to gather these materials, you may do so, and you can always pause along the way and come back as needed. We're going to start with Build Understanding Part 1. Davida draws lines to divide shapes A, B, and C. Which shapes are divided into equal areas? How can you show which shapes are divided into equal areas? Okay, so you're welcome to try this on your own or follow along with me. I'm going to look at shape A, and I'm going to take the triangles and I'm just going to cut them apart. So here I have one triangle here, and I notice that it matches the same triangle that's on the other side, and then I'm going to take this triangle and flip it upside down and move it to right here, and it fits there equally as well. So now I know that all of the triangles in shape A are divided into equal areas. Okay, so now I'm going to look at shape B, and I'm going to take this top section here, and I'm just going to place it underneath. And you can see right away that it does not match the top section to the bottom section. They are not equal. So that lets me know that this shape B is not divided into equal areas. And now I'm ready to take a look at shape C, and I'm going to take one of the sections, and what I'm going to do is go ahead and just flip it. So I'm just going to turn it over just like that, and then I'm going to drag it back up to the other side of the shape, and I see that it fits perfectly and equally. So this lets me know that shape C is also divided into equal areas. So we can answer the question, shape A and C are divided into equal areas. And how can we show which shapes are divided into equal areas? I traced each shape and cut it into parts. The cut parts of shape A and C are divided into equal areas because they fit over each other exactly. The cut parts of shape B are not divided into equal areas because they do not fit over each other exactly. If you would like to pause to write this information down, you may do so. Now let's take a look at part 2. Edgar draws lines to divide circles A and B. Each circle is the same size. Part A. Are the parts of circle A equal or unequal? How do you know? So we're going to do the same thing that we did with the shapes in our part 1. We're going to take a look at one piece of circle A and compare it to the other pieces. And so making sure that all of those pieces are equal and the piece that we take out fits over the other pieces exactly. So here we will take one piece from A, and then we will rotate this piece. Then we will pick it up and place it on top of the shape, and we see that it fits exactly. Now we're going to flip the shape, and then we're going to pick it up again and move it over to this side, and we're noticing that yes, it fits perfectly. And we'll flip it one more time, flipping it, we'll flip it up. So then we'll go ahead and take this shape and place it here, and it does fit perfectly here. So we know that this circle A is equal because the parts that we cut out are all equal because they are all the same shape and size, and they fit over one another exactly. Now let's take a look at part B. Are the parts of circle B equal or unequal? Explain. So we're going to do the same thing. We're going to take one part of circle B and pull it out, and then we're going to compare it. So I'm going to put it right on top, and you're going to notice right away that those are not equal. They are not the same. They do not fit exactly the same. So right away we know that circle B is not equal. And the reason it's not equal, it's unequal, is because some of the parts are smaller and some of the parts are larger and they do not fit equally together. Let's turn to the next page, page 387. We will look at part 3. Raina divides a rectangle into parts. A. Are the parts of the rectangle the same shape? Explain how you know. So when we look at this, we see yellow, green, orange, and pink. And we can see right away that they are not all the same shape. And the main reason is because we see a rectangle that's pink, and we know that that is not the same as the L shape in the yellow and the green shape. Those do not look like the rectangle. So we can answer no, one part is shaped like a rectangle and the others are not. Let's look at part B. Do the parts of the rectangle have the same area? How do you know? Well, area is the number of square units. So let's take a look. We have, in the rectangle pink, we have 1, 2, 3, 4, 5, 6. So there's 6 for the pink one. Let's look at the yellow. We have 1, 2, 3, 4, 5, 6. So they have the same area. How about the green? 1, 2, 3, 4, 5, 6. And then let's take a look at the orange. 1, 2, 3, 4, 5, 6. So all of these shapes have the same area. And we can answer yes, each part covers the same number of unit squares, which is 6. Let's take a look at part C. What fraction of the total area of the rectangle is shaded yellow? And how do you know? Well, we know that there are 4 shapes, and each of those shapes has the same square units of 6. So they're all the same area, but they're different colors. So we know there are 4 total shapes, and there's only one shape that's shaded yellow. So our fraction would be 1/4, and we can explain our thinking. Since each part has an area of 6 unit squares, the yellow part is one of the 4 equal-sized parts. Remember that you can always go back and rewatch this video and pause along the way as needed.